Welcome to the finding parts of text. In this particular section, we'll be looking at how to find the parts of text. We'll be looking at really 3 different sections that deals with different types of text, parts of text. Before most text can be processed, we need to break it up into units. We typically call these units. We often think of these as simply words. This is important because you need to understand the relationship between words and ultimately perhaps the meaning of the words. Specifically in this section, we'll learn how to perform simple tokenization using the Java JDK classes and methods. We'll look at how to provide more complex tokenization using more specialized Java APIs. Specifically, we'll be using OpenNLP and LingPipe. Another important task when we look at parts of speech is find the stem or lemma of a word. The stem refers to the base of a word, the root of a word, and the lemma refers to more what they call the dictionary meaning of a word. And these are slightly different in some respects, and they each have their own place and purpose. Simple Java tokenizers. In this video, we will be looking at tokenization process. Specifically, we'll be looking at simple Java tokenizers. Common task is the splitting of text into elements we typically called tokens. We use a tokenizer for this purpose. You can think of as a token as simply nothing more than a word. So it can be a little more sophisticated than that, depending upon the type of text we're dealing with. We're going to look in this particular video at how we can use the Java SDK and some of its native tokenizers available for the purpose of tokenization. There are more sophisticated tokenizers we'll look at later on that addresses more unique type of problems. In this video, we'll be looking at 3 different classes. We'll look at the scanner class, the BreakIterator class, the StringTokenizer class. We'll be developing a NetBeans project using a new Mavens project we'll use in later videos. With the scanner class, demonstrate how it is easy to use this particular class, and it will suffice for many different instances. We'll look at a BreakIterator class, which provides more detailed information about tokens. And nothing else provides a different way of doing tokenization process. And then we'll be looking at the StringTokenizer class, a general purpose tokenizer. It turns out that we could also conceivably use the stream tokenizer that comes with Java. However, it's no longer really recommended as flexible as the newer tokenizers. In addition, there are other specialized tokenizers such as the Google Guavas API, where we saw a split method in Volume 1, Section 3 video. We will not show that here, but it does essentially the same operation. So let's go ahead and get started with our NetBeans project. So what we start with is a simple print statement to print out a title for this particular example. We'll use this to separate some of the other examples we'll see shortly. We'll go ahead and create a new instance of a scanner class using the sentence that we declared earlier as our argument. With the scanner object now, we then go ahead and use asNext and next methods. We'll also use a token list array list to hold the tokens as we go through there. So we create a token list variable, then we have a while loop. The while loop, we say, well, scanner has next. While there are more tokens available, we'll do the body loop again and again. What we'll be doing is simply using the scanner's next method. The scanner next method simply returns the next token in the list, in the stream that we're reading in. In this case, is adding it to the actual token list using the add method. At that point, we should have an array list containing all the tokens that make up this particular sentence. We'll then use the for each method. This is the Java 8 feature, where we're basically using a lambda expression, taking a token and printing that token out one by one for each token in our token list, and we'll again close that token and open and close brackets. I do this simply to make it a little easier to see the actual output. See what if we actually eliminated all the white spaces. And we also have a couple print line statements to separate the output of this example from subsequent examples. Let's go ahead and build the project. And assuming there are no errors, we should then execute it. Right click, select Run File, and runs the application. As we can see here, we have the scanner class example header. We have 1, 2, 3, 4, 5, 6, 7 tokens all on lines by themselves. In the case of the sentence, we still have a comma, and in case of the word space, we have a period. But notice the blanks and the tabs have been eliminated. So what we can do to eliminate the commas and the periods, if that's important, is use a different method. So let's go back to the actual scanner tokenizer method. After we create the scanner instance, let's go ahead and paste in a line here that invokes the use limiter method. In this case, notice our string consists of open close brackets. These are, since we're using a regular expression pattern, this is essentially defining a class that the tokenizer will use to identify the different items, different elements to use to separate our tokens. In the case inside that, we have the \t, which is for tab. We have a single blank. We have a comma that follows next. And we have a // period. In this case, what this does is says our tokenizer needs to tokenize on periods. Otherwise, a single period has special meaning in regular expressions. It'll match any character. So when we use this method, it should augment or specify, or it should tell the scanner to look at these characters to do the process of tokenization. So let's rerun our project here and see how the output differs. And you'll notice now we have different output. We have more tokens. In this case, we have some null values being returned. We can always skip those if we need to, but notice specifically the tokens do not include white space. The tokens do not include the comma or the period. So this is the example of using the scanner tokenizer. Fairly straightforward method. So what we have here is our header that will start the process. I'll separate the output from the previous one. We want to create an instance of the BreakIterator. We'll use a word iterator, so we're iterating our words. And notice we have the iterator has a static method of getWordInstance. This allows us to create an iterator or provide an iterator that allows us to break on words. We go ahead and use the setText method of this class to use the sentence that we're going to test this iterator out on, which is the same sentence we used earlier. We start off with using the word iterator's first method. This returns an integer value which represents the position inside the string where this particular word starts. I'll go ahead and take this value and store it in a variable called position. Now, if we're we have parsed the entire text or tokenized the entire text, then we will return typically a BreakIterator.done value. We'll make sure that we're not at that value. If we are, we'll drop out of this loop. If we are, what we're going to be doing is go ahead and assigning the position to begin. I'll write it out, position, with a dash, and we'll see how this is used in just a moment. We'll go ahead and use the next method to get the next word, and that will give us, again, the position. Again, if we're done, we'll break. Otherwise, what we're going to simply be doing is printing out the initial position, plus take the sentence, look at the substring of that, is a substring method of this string class, starting at the begin, going to the position element, this non-inclusive in this case, as we did before, and close this and open close brackets. And we'll go ahead and run this project again. Let's go up and look at the output in this case. What we see here is a number of tokens. In this case, the tokens that are generated includes the A blank here, a simple, another blank sentence, etc. In this case, we may need to, when we use this more extensively, remove these particular white spaces or special cases like the commas and the periods. Notice at the very end, we also get a value which is not necessarily a token. This is because in the actual if-then-else statement we had, we encountered the BreakIterator after we got to the period. So what happens down here is this starts the actual period, or actually started after the period, and we didn't have a token, so we never really completed this output line. The print line never was executed. Nevertheless, this is a particular tokenizer that's not well known necessarily. It does provide you a couple of interesting methods to access it. Should it become useful, we may want to use this particular type of iterator. What we're going to do now, however, is to move on to the StringTokenizer class. And let's see what we have here. Again, we play a simple header. We create a new instance of a StringTokenizer called StringTokenizer. In this case, we're using the StringTokenizer constructor that has a sentence or a string. This is what's going to be tokenized. And then we'll use the has more tokens to see if we have more tokens. As long as we do, we'll go ahead and print out the next token. The next token method returns the next token and enclose that between the open and closed brackets. What we need to do before we run the code is go ahead and invoke this particular method. I'll and copy the name of the method, go back up to the main method, paste it in. That way it invokes all three tokenizers in this case. Go ahead and run the file, make the output a little larger so you can see what the output looks like. And what we see here is the output of the StringTokenizer example. In this case, we have essentially the same output we had with the original scanner example before we used the use delimiter method. But you can see it works really easily. In some cases, this may be a better technique to use.